So, John, we've been looking at edge-triggered interrupts, but can you show me an example where you can show all the steps done right?
Okay. Now, edge trigger is awesome because you're going to get an interrupt right when you touch the button. No waiting, no anything. Okay. So this is a fairly complicated example. Let's go step by step. What Ramesh has built for us are 4 switches tied to these 4 pins, PB18, PB24, PA22, and PA8. And since they're positive logic switches, we're going to have an interrupt on the rising edge. Okay, so the first lines here, 23 through 26, are just setting up a regular input. Now, for each edge-triggered interrupt, there is this polarity register, which specifies whether you want to have no interrupts, an interrupt on rising edge, an interrupt on falling edge, or an interrupt on both rising and falling.
So that means I need 2 bits for it.
So every pin of your microcontroller has got 2 bits in this field. Okay? So the value 1 here means it's a rising edge. And all this shifting is the magic that you have to do, for example, to make a rising edge on PA8, and then a rising edge on PB22, rising edge on PA22, a rising edge on PB18, and a rising edge on PB14.
So it seems like if I put like a 0, 0, I'm turning off, 0, 1, maybe I'm doing a rising edge, a 1, 0, I'm doing a falling edge, and 1, 1, I'm saying both edges.
Perfect. And in this case, we're going to just interrupt on the rising edge, i.e. when you touch the switch.
Okay.
All right. So that's the polarity register. Okay. The next register we're going to talk about is the iClear. Now, this is one of those fancy, stupid registers that's not memory. And when you write a 1 to the iClear, it clears the corresponding trigger bit.
The RIS bit.
The RIS trigger bit gets cleared by writing 1s into the iClear register. Okay? So we're going to clear bits 8 and 22 because those are the ones we're going to use in port A. We're going to clear bits 18 and 24 in port B because those are the pins we're going to use. Okay. And so it's a good idea to clear the flag during the initialization so your first interrupt occurs after you've initialized. All right, now the interesting one is the iMask. And again, for every pin on your microcontroller, from port A, bit 0, all the way up to port B, bit 28, there's a bit in the iMask to say, let's interrupt, and we call it the ARM bit. So I'm going to ARM bits 8 and 22 in port A, bits 18 and 24 here in port B, and that will arm those 4 switches to cause an interrupt.
So anything connected to it, if it has a rising edge or whatever we set the event for, will now be armed for an interrupt.
Yep.
Okay.
Every interrupt on the machine, you can set a 2-bit priority field. This is going to be a group 1 interrupt, which turns out to be this location here. It is interrupt number 1, which is why there's a 1 shift here. It's bits 14 and 15 of this IP priority register, setting it to priority 2. Okay. And then what's going to happen in our program is we're going to increment these global variables, each one on the switch. So my main program is going to run at 80 megahertz. We've shown you the initialization, we cleared the flags, and then the main program doesn't do anything. All the magic happens in the interrupt.
Okay. So, John, it looks like you have one handler called the group 1 IRQ handler. So are you saying that no matter which of those 4 pins buttons I press, They all come to the same handler?
Yes. As a matter of fact, throughout the 60 pins on the microcontroller, if you set up any one of those 60 pins or any group of those 60 pins to trigger on an edge, it's going to be in the same handler. So we call this a we call this a polled, not a vectored, but
Yes.
a polled interrupt, because once I get to line 55, I don't know which switch caused it.
Because it's pulling all of them into a single interrupt. It's
Yep. So how do you suppose I'm going to figure out who is the culprit?
Well, it looks like we had that flag you said, which was the flag that tells us which interrupt occurred, right?
Yep, that's that RIS flag.
The raw interrupt status.
Again, so all 60 pins on the microcontroller have a bit, either an A or an B, which will say, in this case here, RIS bit 8 is going to tell me whether PA8 triggered an interrupt. So that's the if statement there.
Mm-hmm.
So I'm going to be in line 56 if PA8 caused the interrupt.
Okay.
And so what do you want to do when the interrupt happens?
For now, we're just gonna keep a count of.
Yeah, we're going to count, how many times I push the button. But this line 56 here is critical because I got to acknowledge the interrupt, which means I got to clear bit 8 of the RIS. So it doesn't interrupt me over and over and over again.
Yep.
Okay. And so we got 4 pins. So it's possible you could push 2 buttons at the same time. So we're going to poll, which means look at each pin, each switch individually. Again, port A, bit 22, port B, bit 18, port B, bit 24. All right.
Okay, so let's run.
Yeah, stop talking and let's run it. All right. All right, so we have continuous refresh on, and I'm going to hit the go button here, continue. All right, so let's push PB18. It came on. Good job. Let's try PB24. Touch, it comes on. Let's try PB24 again. All right,
Okay.
so you can see that every time I touch a switch, it increments.
Okay, I'm gonna try one on the port A.
Yeah, good job,
There's
Ramesh.
the one.
All right,
Let's do it one more time.
there you go. So every time you push the switch, you get an interrupt, and it will poll to see which one caused the interrupt. And in this case, it services the interrupt that it was after.
All right.
There we are. Good job.
Thank you.